Hello guys and welcome to our first lecture in physics for grade 11. Today we will talk about module 9, which is about momentum and its conservation. So our first lecture is about impulse and momentum. What's the meaning of impulse and momentum? In the beginning we will talk about momentum. Suppose that we have two balls. One of them is small and the other is bigger. And here we have a window. If you throw these balls to the window, which one will break the window? If you said the bigger one will break the window, so that's true, because it has the bigger mass. If you said that the small one will break the window, so that's also true, because if you throw the small one with enough velocity, so it will break the window. In physics, we cannot say that. In physics, we said that if the object has enough momentum, so it will break the window. So we should have a law for momentum to calculate it. Maybe you remember in previous studying that the second law for Newton, which is F equal to ma, the force equal to the mass multiplied by the acceleration. And you know that the acceleration is equal to delta v over delta t, the velocity interval over the time interval. So here our equation will be F equal to m delta v over delta t. If you multiply the two sides by delta t, if you multiply the two sides by delta t, so we will have f delta t equal to m delta v. And this is the general equation that we will use in this module. What's this equation meaning? Here, the left side of the equation, which is f delta t, we called it impulse. F delta t is defined as the impulse. So here we have the impulse. We can put a definition, of course, for the impulse from the equation. So the definition of the impulse is the product of the average force on an object and the time interval over which it acts. Again, the definition of impulse is the product of the average force on an object and the time interval over which it acts. And this definition for impulse, it comes from the equation. So impulse, by the way, we don't have a symbol for impulse. In physics, we just write impulse. So impulse equal to, I will write it here as IMP, and you can write it as IMP or impulse is the same. So impulse equal to F delta t. This is the equation for impulse. And what's the unit for the impulse? We know that the unit of the force is Newton, and the unit of delta t, the unit of the time, of course, it's second. So the unit of the impulse is equal to Newton multiplied by second. And here we have it. Impulse is measured in Newton multiplied by the second. Now the right side of the equation, which is m delta v, that one is the momentum. Here we have the momentum. Also, we will put a definition for the momentum from the equation. So the definition of momentum is the product of the object's mass and the object's velocity is defined as the momentum of the object. This is the definition of momentum. Again, the product of the object's mass and the object's velocity is defined as the momentum of the object. So now we have the momentum. The symbol of momentum is P. So P equal to m delta V. This is the law of momentum. So what's the unit of momentum? We know that that means the mass. The unit of the mass is equal to kilogram. And the unit of delta V, or the unit of the velocity, is meter per second. So the unit of momentum is equal to kilogram multiplied by meter per second. Or you can write it as this: kilogram multiplied by meter over second. It's the same. So here we have the law of momentum, and also you can see it right here. This is the momentum, and delta V, the law of momentum. We can write the equation as this: P equal to mv, and we can write the impulse momentum theorem as F delta T equal to P final minus P initial. This equation is come from delta P. That means F delta T equal to delta P, because we know that F delta T, the general equation that we had in the beginning, which is equal to m delta V. M delta V, we have it delta T here equal to m V final minus m V initial. So F delta T equal to mv final minus mv initial. So we can write our equation like this, or we can write it like this: F delta T equal to P final minus P initial. P final is the same. M delta V final is the same to P final. And here we have the minus, here we have the minus. And P initial is the same if we write it like mv initial. So we have the first example for our lecture here. Here we have an example, problem 1. A 2,200 kilogram vehicle traveling at 94 kilometer per hour, or 26 meter per second, can be stopped in 21 seconds by gently applying the brakes. It can be stopped in 3.8 seconds if the driver slams on the brakes, or in 0.22 seconds if it hits a concrete wall. What is the impulse exerted on the vehicle, and what average force is exerted on the vehicle in each of these stops? So, in the beginning, in every question that we will have in our studying, in the beginning we should write the noun. So what's the noun that we have in this question? In the beginning we have 2,200 kilogram. This is the mass. So we have the mass of the vehicle, which is m equal to 2,200 kilogram. Traveling at, because here we have the time in second, and here we have the time in second, and here the third one we have it in second, so we will choose 26 meter per second. So the first velocity that we have, v initial, equal to positive to 26 meter per second. Here in the question, he tell me that can be stopped. Because of he can be, it can be stopped. So we have V final that's equal to 0 because the car is stopped. And after that, he told me that delta T, the first one, is 21 seconds by gently applying the braking. So delta T, gentle braking, is 21. And after that, here he told me that it can be stopped in 3.8 if the driver slams on the brakes. So the hard braking, that's equal to 3.8 seconds. And if the car hits a concrete wall, it will stop by 0.22 seconds. So delta t when hitting a wall is 0.22. He need to calculate impulse that exerted on the vehicle, and after that the average force that exerted on the vehicle. So the first one, what is the impulse? We know that the impulse, and we said impulse, which is F delta t equal to P final minus P initial. But here we don't have P final and we don't have P initial. So in the beginning we should find P final and P initial, and after that we should know the impulse. So in the beginning we will calculate P initial, and after that we will calculate P final. So here we have P initial equal to M V initial. M, we know it is the mass, and we have it in the question, which is 2,200 kilogram. So 2,200 kilogram multiplied by the velocity, which is V initial equal to 26. So after multiplying 2,200 by 26, the result will be 5.7 times 10 to power 4 kilogram multiplied by meter per second. This is P initial, or the first momentum. P final, we should calculate it, which is mv final. M is the same vehicle, so we have 2,200 kilogram. But V final, he told me in the question that the vehicle is stopped. So the V final, it will equal to 0. So 0 multiplied by any number, it's equal to 0. And after that, we will write our equation, which is F delta t equal to P final minus P initial. F delta t equal to P final, we calculated, which is 0, minus the P initial we calculated, which is equal to 5.7 times 10 to power 4. So the final result will be minus 5.7 times 10 to power 4 kilogram meter per second. This is the part one of the question. The second one, what average force is exerted on the vehicle in each of these stops? So he need to calculate the force in T1 and T2 and T3. We know that we have a law which is F delta T equal to impulse. We calculate the impulse here. The impulse here, we have it. So we have impulse equal to F delta T. So he need to calculate F when delta T 1 and delta T when delta T equal to 21, and the second one, which is 3.8, and when T equal to 0.22. So in the beginning, we will calculate it when the T equal to 21. So delta T, sorry, we need to calculate the force. So force equal to impulse over delta T. And here we have the numbers. So F equal to minus 5.7 times 10 to power 4 over 21 second. And the result will be minus 2.7 times 10 to power 3 Newton. The second one, when hard braking, the F for hard braking, the same law, is equal to impulse over delta T, which is minus 5.7 times 10 to power 4 kilogram meter per second over delta T, which is 3.8. And the final result will be minus 1.5 times 10 to power 4 Newton. The third one, when hitting a concrete wall in time which is 0.22, so F equal to minus 5.7 times 10 to power 4 kilogram meter over 0.22, and the final result will be minus 2.6 times 10 to power 5 Newton. I hope that you understand our lecture for today, and in the next lecture we will try to solve the practice problem in the next lecture, inshallah. So see you in the next one.